Hi everyone, my name is Amrita Kosanam and I'm a junior at Tompkins High School. So today I'm going to be talking about another group testing method, and it's an even more effective method than the Dorfman method. And if you want to see an experiment about the Dorfman testing method, you can check out my last video, which is linked below. Before I get started with the experiment, I would just like to thank Dr. Krishna Narayanan from A&M University for getting me involved on this project and providing me with the opportunity to learn about and show different group testing methods in this experiment today. I would also like to thank Dr. Sangeeta Khare and Dr. Gokulan Kupan for providing their help with the concept and project as well. Okay, so now I'm just going to explain how this works, the binary group testing method. How this works, well, I have a chart here. At the top of the columns, there's S1 through S15, which represents sample 1 through sample 15. And then at the rows, I have test 1 through test 4. And these are actually grouped or pooled tests. They're not individual tests, so these are going to have multiple samples within them. These 4 tests are all that we need to test all 15 samples. Let's say that sample 9 is our infected sample. Sample 9 is represented in binary as 1001, which you can see as you just read down the column. And that works for other numbers too. Sample 5 is represented in binary as 0101. So how this comes into play into the group testing method is you're going to go through each of the rows, each of the tests, to determine which samples need to be included in which tests. You go to the row and you see, well, which samples have a 1 under them that lie in that row. So for test 1, for example, I have sample 8 through sample 15 going into test 1. I have 1s under all of those. Let's say for test 3 now, I'm going to put sample 2, sample 3, 6, 7, 10, 11, and 14 and 15. So whichever sample numbers have the 1, whichever sample numbers have the 1 in that row, that's the one that's going to be included in the pooled test. So going back to how we said, let's pretend that sample 9 is the infected sample. Well, if we think of sample 9 as our infected sample, it's going into test 1 and test 4, not test 2 and test 3 because there are zeros there. If test 9 is the infected sample, that means that part of its viral load is being included in the pooled test for test 1 and test 4, but not in test 2 and test 3 because it's just not included in there. So when we get the results back for each of these row tests and we just go from order 1 through 4, we're going to get a positive, negative, negative, and positive. If you think of the positives like the 1s, if you think of negatives as zeros, and you kind of convert that to a binary number, positive, negative, negative, positive, will give you 1, 0, 0, 1. And that represents how sample 9 is the culprit. It's the infected one here because it was included in test 1 and test 4, but not in test 2 and test 3, which is why those were negative. So now I'm going to be showing the actual experiment about how this works, and I'm going to be testing 15 samples here. I have them 1 through 15, and they're going to be grouped like how I explained previously. So I have 4 test tubes, and these are going to hold the 4 pooled tests since we only need 4 tests to test all of these 15 samples. The infected sample is going to be number 9, so I'm going to fill this with 1,500 ml of the glucose solution. The rest are all going to just need water, and fill the rest with 1,500 ml of plain water. So now I'm going to take 250 ml from each sample to put into their respective pools. Each pool is comprised of a certain pattern of samples, so I'm going to put those respective samples in their corresponding pools. Now I'm going to put each sample into their respective pooled samples. One will go into pool number 4. 2 will go into pool number 3. 3 will go into 3. And 4. 4 will go into 2. 5 will go into 2 and 4 and so on. Okay, so I filled up the 4 representative samples with their respective individual sample tests, and now we're going to test each pooling sample. Before I do that, I'm just going to put the top on each tube, and I'm just going to shake it to make sure that whichever one has the infected sample, that the glucose is clearly mixed into the rest of the liquid. So now I'm going to test using 4 test strips. So here I have 4 tests ready for all 4 representative samples. I'm going to start the timer for 3 minutes.
So 1001, which represents 9. It did work. Right? No, Paina, why don't you write samples 1001, 1, 2, 3, 4, and write bit.
I'll write the testing numbers.
1, 2, 3, 4.
No, well that
It should be bit number 1, bit number 2, bit number 3, bit number 4.
Okay. Okay, so now the 3 minutes has passed, and now the test strips are ready to look at. So as I mentioned before, when a test strip comes positive, we can identify that as a 1. And when a test strip comes negative, we can identify that as a 0. So what we're looking at here is positive, negative, negative, positive, which means it'll be a 1, 0, 0, 1. And I'm going to look at which binary number is 1, 0, 0, 1, and that's 9. 9 is the sample that I put glucose solution in. So that's how you know this works. You can see the test strips that had no glucose in them at all, or are negative, have stayed yellow. But the test strips that had glucose in them, the infected sample that's 9, have changed color and they've become darker, become green. So this test, I tested 15 samples and I only needed 4 tests. So comparing this to Dorfman, when I tested 16 samples, I needed 8 samples for those. So as you can see, this method is much more efficient and it's definitely a very interesting group testing method.